Okay, can you see it?
Yes, ma'am.
All right, so we only have 30 minutes, maybe a little less than that. No, they were running behind. And so I am Dr. Janine Walton. Some of you are I'm familiar with. I was in a workshop with Alba this summer, with Georgia Tech.
Yes.
So we are going to talk about unpacking the Georgia CS standards for K through 8. And for the agenda, we are going to have a standards overview, tried and true activities, and resources. So if there are any links, we can share them in the chat. I'll ask Yolanda if she can share them in the chat as I go through some of the slides so that you guys can have access and start building the library of resources. And if you have any resources that you would like to share, please make sure you share in the chat. And so the standards for computer science, Georgia has a standards of excellence, and there are several themes which are empowered learner, knowledge of construction, digital citizen, which is making students aware of what they use every day as citizens. They use technology, they have it in their hand, they know the passwords to open up the devices. And so that will show them how to be good digital citizens and start with safety and practices and forming good habits when using technology. They have innovative designer and creative, computational thinker, creative communicator, global collaborator, reflective researcher, and digital awareness. And so this is a good idea to get your teachers to come up with themes as well when they're building a curriculum around CS to help students engage in the content. And so standards for K through 8, a visualization. If you look at the chart, the word art, there are a lot of keywords here: data, test, program, solving, design, creating, discussing, games, examples. And so you can have your teachers or your curriculum developers look at the keywords and come up with some ideas on how they want to apply these concepts and keywords. For 3 through 5, there are some processes, word, computers, finding the appropriate problems, identifying, designing, example, and some of these will overlap because we are working with themes and we are working with concepts, and the concepts in computer science don't change. It's just that at the different levels, you may introduce different curriculum, different activities in order to meet your learners where they are, okay? And then 6 through 8, you'll start seeing some of those same words: develop, design. This one you get into websites, digital, game, user, loops. You get into some of the words for programming in the back end of using the computer or some type of technology. And then K through 2, they have processes, global, positive user, model, analyze, building, being authentic, considerations, different tasks, the keyboard. And so you can introduce some of the basic languages that they may hear all of the time. You know, they hear all the time. And so this is just a visualization chart just to get you an idea. And so some of the things that you can do are unplugged activities. Now, unplugged activities will take you away from the computer. And so when teaching computer science, of course, we use technology, but we also want to bring it back to the classroom, like on the carpet in elementary, with story time. And so some of the topics that you can use unplugged activities are binary numbers, image representation, search and algorithms, error detection, kid bots, and sorting networks. But there are several resources for unplugged activities. Now, unplugged activities might look like things that the teacher has cut out, cards, books that you're going over a topic. Maybe students may do some role playing and things of that nature. but they won't be using any devices at this time. So they will be discussing computer science concepts, but it'll be in a creative way. So they may be asked to make something, or they may be asked to represent something in a story time or circle time. So some of the books, we'll share some books if you need some more additional resources, but Going Places is a book that deals with computer science. I think we have some other books here listed. So one of the things that I suggest is that you get your media specialist involved. And if they don't have a section for computer science in the library and you're trying to initiate computer science in your school or your district is mandating computer science be implemented in some way, make sure you get with your media specialist and see if they have some of these books on hand. That way the teachers can have students check it out, or the teachers can check it out or start to build their library inside their classroom. Because I know teachers have libraries in their classroom, but there's also a wider range that should be in the media center. All right, First Book Marketplace and First Book National Book Bank. These are some resources where you can get information on books. There are also magazines, so they have downloads or free PDFs, and the link is right there, raspberrypi.org/books magazines. So there's several ways. I know the Media Center likes to have a variety of media for students, so they have magazines, they have books. So this is just some good resources to have a variety. And then another thing for Unplugged Activities will be the design process that's used in engineering. And so this process teachers can have this as a chart in their room where students can understand the process and get familiar with what goes into these different categories. So ask, imagine, plan, create, test, and improve. And so this can be something that teachers can use to create lessons, to go over the different concepts, and to build different activities. And so this is an image of what computer science in the classroom might look like, as far as teachers can use things that they already have, such as tape. I know a lot of times teachers use the tape to tape up the board and divide it off. They have some Q-tips, paper, paint. So these are some of the things that you can use and get creative with in activities. And here you see students making things and using scissors for unplugged activities. So this is how you can get them involved in the concepts. And it's really them being creative and showing their creativity. So it just shows you that it's the possibilities are endless when it comes to computer science and what you can introduce on the elementary level. And so this is Disney Parks, How to Draw a YouTube series. So I won't play the video just because of the sake of time. And I want to make sure we get through all the slides, but this goes a step by step to show students how to draw and how to animate, basically from, the paper and tracing. So these are fun activities that the teacher can do with students as well. And here you see the students basically drew their version of Donald Duck, and you can see some students did, they all basically look similar, but you can see the different variations where students got creative. Like this little girl in front has a bow on hers. The girl on the other side has a hat. And so there's just different things going on. Okay. So you can get a closer look up front that they really did good as far as tracing, and they probably surprised themselves if they are not drawers. So that's just another way to build confidence in your students. All right, and so software and programs. So we have some software and programs that we're gonna go over. So this will help you build your resources. Tinkercad is one program that you can use to help build animations or games for computer science. And they do have the elementary level. You know, it is more of an elementary level that you can use. They have Microsoft Make Code. Microsoft Make Code is another software that you can use where they have different things. Like here in the top, you see the microbit. And so if you click on each icon, you'll go into a different division for this maker code. And the teachers can get familiar with this and start bringing this into the classroom to build activities. All right, and then Scratch Junior. Yolanda, can you talk about Scratch Junior real quick for me?
When they were saying building things block by block in the last presentation, Scratch and Scratch Junior are block programs that get students coding. To take that a step further, Janine has gone to Scratch Encore, and Scratch Encore has a curriculum built around Scratch that engages students with Scratch, and it's especially good for students at the elementary level who have not been exposed to block coding.
Hold on 1 second. Let's see, hold on, guys. Okay. Are you on Scratch Encore?
I just did that one.
Okay. All right. And so the next thing we have is Future Problem Solving Program International. And so there are like 250,000 future program students. There's 37 states and 14 countries involved. So this is another way to get students involved globally, so that if a lot of schools' missions are like to be globally competitive. And so this is a good program to have your teachers be involved in and get the resources. And then CodeHS is another software that a lot of teachers use all the way to high school. So in high school, we definitely use CodeHS, but they do have some fundamentals sections for students, and they have videos, they have different projects or activities, and the students just go through them one by one. And so this is something that your teachers can look at to see if they want to add some of the courses that they have into their curriculum. So it's not something that they would just put the students on and leave them. It's something that they can implement into the curriculum that they already have or that they're developing. Code.org is another one. I know they mentioned it. In the session earlier. We gave some information about code.org. So code.org has a lot of fun things coming up. They have the fundamentals, the CS fundamentals. And so that's going to be a layout where this is a good place for your teachers to start. So CS fundamentals is going to give you the breakdown. It's going to give you the concept. It's going to give you videos. It's going to give you resources. It's going to give you a lot of the resources, a lot of activities, and it also has what I like are what's called plugins, where basically it's just the simulators where students can actually see their work and what they code online. Okay, and so they can test things out and actually run it back and see what they built. So that's either in a game or it could be an app. And another thing that you mentioned that I don't know if we have here is CS Journeys. And CS Journeys is what is going to be them going on field trips, okay, virtual field trips. And so that is a great thing, especially since a lot of schools will be limited funds, and most likely be virtual or field trips may not be available based on your district's restrictions to the public. Okay, so physical computing. All right, so physical computer involves interactive systems um, that can help you respond to the world around you. So it's going to help students respond to what's around them. And some of those will be Raspberry Pi. And so these are little devices, little technology that are handheld. Students can actually use them, build different things. They can code and make these Raspberry Pis function. Actual computer with a smaller device. And there are different activities that go along with this device. So you can order the kits online, and there are a lot of different activities that the teachers can use to go along with these kits. So they can have, a kit for each student, or they can, based on funding, they can, they have to, if they can only order 5 and not one for each student, then they can do it based on groups, and they can just try to give everybody a role. So that's one way around anything that's like dealing with funding. You don't have the money to get enough of the Raspberry Pis. Teachers and educators, this computing is vital aspect of today's world, where they empower teachers to give young people the skills that they need to shape the world. So they provide a high quality CP training, course classroom and resources, online events for teachers, and it's all free. So I would take advantage of this by going to the website and allowing the teachers to be trained. They can do self-training, or you can hold a workshop where they log into the computer and see what's available for, or what events are coming up. BBC microbits. So microbits are very much fun. They are something that I used this summer with Georgia Tech. And there are so many things that you can do with the microbits. The possibilities are endless. And so this is something that you can also have teachers purchase for students. They can also work in a group if they don't have enough to, if they don't have, funding to buy every single student a microbit. They can buy a class set where they know they're going to have, they can break students up in a certain amount of groups, and they can get involved. So they can take turns, and they can work together as a team, because one of the things that we want to get the students to realize is that computer science does involve working in a team. So they will work for any company, computer science, whether it's Google, Facebook, Twitter, or work somewhere like Georgia Tech, they will be required to work together as a team. So we want to build those skills. And so using the Raspberry Pis and the microbits is a great way to get students involved. And once they see how they work and what they can do with them, I think they will enjoy it. I think you will capture your audience, and you will build self-lovers of computer science. Another thing is Makey. Now, Makey is a tool, it's accessories that actually work together with Scratch. So this is something where it will actually make it more fun, to where it's almost like a video game for them. So students are already playing video games and working with joysticks or controllers. This is something that will bring whatever they created to life. And so it's just a fun way to enhance what they've coded. So you can plug these in, and there are so many things that you can do. I would suggest going to the website, looking at tutorials, and seeing what you can do. And the accessories are not that expensive. You can also get them on, kits on Amazon. But if you go straight to the Makey website, you'll see some of the kits that have different starter kits, or you can start with one accessory that you want to work with. But this does work well with Scratch. Okay, so this is just showing you images of students in elementary actually working with the Makey. So as you can see, like I mentioned, the one on the left looks like a little controller, and so it's an accessory that goes right with what they coded in the classroom, and it just enhances it. And so it just makes it just another level of fun of what what they do. Is another one that you can go to. Expressive technology with paper circuits. And so this is another way to involve students in a different light. So they may be interested in journaling or bringing their creations on paper to life. So this is just something that they can connect in a different way. And so you'll be able to reach different learners. And so here's just some images, just showing you when the different objects come into the school. They're actually in the media center right now, and actually using the device. So you can actually have your media specialist have some type of training, and or a teacher can volunteer to offer maybe like a class for a certain grade levels. Let's say second grade wants to come into the media center on Thursday, and they want to work with one of the objects that you have. Another thing is when you order the devices that you have, you can keep them in the media center. So when you order the devices, you can keep them in the media center, and then hold classes in the media center. But it probably, due to COVID, it probably would be best to try to get, class sets, or monitor what you have in the media center and just make sure that you wipe things down for sanitation purposes. So,
Janine,
yes.
I think it's time for us to go back to the main session.
Oh, yes. Did he call us back? All right. So I don't think it's that many left. Is it, Yolanda? It's not that many.
There's not. No.
All right.
No.
So CSRall is for communities. So we'll give you resources on communities. There's Code Club. There's raspberrypi.org, Girls Who Code. What else? CSTA. We'll be having events to help elementary teachers coming up soon, I think on the 24th. And so I don't know how we get back. I don't see it. Do we just go back?
Yes, I think you just go back to the first link that we had.
It didn't pop up on my screen, so let me see. Is it popping up on your screen?
And when they were talking, they just said come back to the main.
Just come back.
Yes.
Okay, so we'll just go back. So that really is it. We'll just go back. If you have any questions, you can reach out. I guess that's it. So we can just go back to the link.
Yes, ma'am.
Okay. All right.
Thank
See you in
you.
another room. Okay.